Hello everybody and welcome to the Network Principles section of our CCIE written section. In the following several videos we will be covering a multitude of different topics and technologies ranging from theory-based technologies where we're going to get into some of the more complicated aspects of how networks work. We're going to be looking at a variety of things like what I've done right here is I've taken the written exam blueprint and I've pretty much copied it into OneNote, and I have set it up to where as you guys are going through this with me, we're going to cover iOS and iOS XE, Ceph, and all the other breakdowns to each one of these technologies we're going through. So as we're covering something, we'll go into deep dive. This will keep us both on track for how things are working. If you would like this OneNote outline, I'll be more than happy to send you the file for it. I'll upload it to like Dropbox or ForShared or something to that effect so that you can utilize it as well as I can. So in this first section we're going to talk about networking principles. So the concepts and theory that goes in, that will drive how we learn the material going here forward. So the very first thing that we're going to cover is iOS and iOS XE. So the first thing that we're going to cover is what is iOS and what is iOS XE? Well, as you can see, I already have a pretty good baseline as to what it is and how we're going to work with it. So, most of you know Cisco iOS. That's going to be what you use on Cisco routers and switches. So, most cases, most people have played with this, whether it's through Packet Tracer or GNS3, something to that effect. So when you get a situation where you're in a network and they have multiple multiple aspects of Cisco equipment, so they might have the Nexus platform inside, they might be running on the MDS platform with the UCS chassis, you might be working for a service provider where they have iOS XR. So I'm going to take a couple minutes and explain what each one of these variations of code are, how they work, to a very, very low level, or a very high level of each one, just so you have an idea of what each one works. And then we're going to get into the complexities and understand the differences between iOS and iOS XE, how iOS works, how iOS XE works. And that's going to be kind of crucial for those of you that don't work in, you may or may not work in a production environment. If you are not in a production environment, it's going to be one of those things where if you don't understand how the different operating systems come into play, what platforms they work on, where they come into play, that's going to be difficult for you to troubleshoot, because if you're like me back when I started into Cisco, you understood what a router did, you understood what a switch did, but when you were actually thrown into a production environment, you kind of were like, what do I do? So I'm going to try to take that what do I do out of the equation altogether, and we're going to talk about this. So iOS, as most of you know, is going to be the internet networking operating system. So this is going to be what routers and switches work on, right? So this is going to be what we configure our IP addressing on, our EIGRP, OSPF, our switching, things of that nature, ACLs, NAT, iOS-based IPS if you're in security. So this is what we're going to cover right here. So iOS is going to be the main staple that we're going to work with throughout this entire video series. Actually, the only one. I might touch base very, very lightly on Cisco iOS XE inside of the CSR 1000V, which runs iOS XE. Now, most of us have run on iOS, and most people, at least the ones that I've worked with, they've dealt with 12.2 through 12.4. Whether it's IP services or it's been, advanced enterprise service, something to that effect. It really doesn't make a difference where you've laid your hands on the equipment or what level of features have been available to that operating system. What comes into play is this right here, the version you played with. Assume this is like Windows 7, and then 15.x, and in our case T for the T train. That's going to be what we're going to deal with like Windows 8. So that's what we're going to be dealing with throughout this entire series. We're not going to touch 12 at all. I was going to play with that a little bit until I got the server. We don't have to worry about that. So this is what most people have dealt with, is 12.2, 12.4, somewhere in there. 15x is where it's at nowadays. If you go online, you're going to want, and you're looking for CCIE version 5, 15.x, anything is going to be a benefit to you. Now, different platforms like the 1841, the 2811, 2821, things like that, these are going to be limited down to, I think, 15.1 is the highest code train they have available to them right now. Now, in our environment, we're going to be running 7206s, they're VXRs, and we are going to be running 15 to M4. That's going to be what we're going to be running in our environment, and this is going to be Advanced Enterprise Services. And that's what we're going to run with, and that's how we're going to do everything we need to do for our exam. So once we get that situated and everything out of the way for that, that's what we're going to be dealing with. So moving on, the next one we're going to look at is going to be iOS XE, or I'm sorry, XR. I'll talk about briefly what each one of those is. So we're going to talk about iOS XR briefly, and XOS, and iOS XE. So if you're dealing with iOS XR, you're probably working for a service provider. Now, if you're dealing with XR, that's going to be another level of operating system, typically used on things like the 10,000 series router or the 12,000 series router, the carrier services router, carrier route series. This is what they use in ISPs. So that's what you're going to be dealing with that. If you're dealing with the data center, like the Nexus platform, you're going to be dealing with NX-OS, which if you play with the MDS platform, that's what you're going to be running on. Now, with that being said, if you are a LAN/WAN engineer, so somebody that deals with just iOS, and you get called in to work on XR or NX-OS, are you going to freak out and not be able to do it? Well, you're probably going to be able to fudge your way through it with everybody's favorite context-sensitive help icon, which is the question mark. I use this quite a bit, even as and I think I'm pretty well versed with Cisco iOS. I still have to do question mark whenever I'm on NX-OS or XR. I have no choice. I just have to do it. So what Cisco has done is they've allowed, especially with the XE platform, this guy right here, the XE platform is very modular. So what they've done is they've allowed XE to integrate all of these different performance operations inside of different services and packages. And we'll talk about those in just a minute. But where you're going to get the most bang for your buck, and where Cisco is eventually going to move to, they're going to get rid of iOS. So iOS is going to go away. They're going to move to an iOS XE architecture. What that does is it's what they call a distributed control plane. So DIST CP, distributed control plane. Where right now, if you're on a ISR, can't write here, ISR G1, so an 1800, a 2800, a 3800 series device, you're on a G1, meaning you have one route processor and one control plane processor. It's actually the same processor back to the same CPU. So the same CPU is doing both. Now with the ISR G2, the 1900 series, 2900, 3900, so on and so forth, these guys have two CPUs. And what they do is they allow you to run one CPU, does all of this stuff, so the routing and the control plane, or the the route processor and the control plane processor, but you have a secondary CPU for running other things on top of that device. So, and if you look up Cisco documentation, it says Linux-based applications. I'm not exactly sure what they mean by that, but that's what you have the option for. Now, this is ISR. This stands for Integrated Services Router. This is what you're going to see at the branch edge, or maybe the branch core. Now, we're going to look at iOS XE now and take a look at how that actually works. So we're going to look at iOS XE and how some of its aspects work, just so you guys have an idea of how this actually all comes together. So let me bring this down just a little bit. So one thing I want to touch on when it comes to iOS XE, they've made iOS XE very modular, very flexible. As you spend more and more time inside of the IT industry, the way that the trend and the way that the industry seems to be going is more up to a flexibility aspect, meaning you're going to have what they call APIs, or application programmable interfaces. What this basically does, it allows a vendor, let's say like EMC for instance. EMC is a storage solutions provider. Put the little square there. EMC, they're a storage provider. They have an operating system, or an application if you will. I'm not exactly sure what they call it. Well, I use NetApp at work, but they give you an application that allows you to divvy up how the storage array sends its storage capabilities to the rest of the network. So the SAN, the storage area network. So what the programmability aspects of it, what the API does, is it allows you to have like a third-party company come in and write an application. So you get a developer, an app dev guy that comes in, he writes an application that's going to be able to integrate with EMC so that you can use, or better use, make more utilization out of the extensibility, what they call XML, extensible markup language. Gives you better extensibility to your devices. So VMware's been doing that lately, or I should say VMware has been doing that a lot lately with their 5.5 release of vSphere and vCenter. What they're actually allowing you to do is they give you more flexibility when it comes down to the way storage is divvied up. So very cool what they've been doing lately. So let me talk now about how I ran out of Control Z on that one. Let me talk about now what the different platforms you can find iOS XE on, and where you would potentially need to migrate. If you're going to migrate, what you can potentially see in the environment. Now, at work, we have an ASR 1000. Was it a 4, 2, 4, 6? I think one of those. I don't really know. I've never paid really much of that attention to it. I've only laid my hands on it once, and that was to make sure that something was physically plugged in. But the ASR 1000 aggregating services router, this is going to be for your data center, or data center router. It's got a higher throughput than the ISRs. So that's for one. Now, the benefit to the ASR is they come shipped from Cisco running iOS XE. So the platforms you could potentially see running iOS XE out of the gate are the ASR 1000s, the CAT 4500E running the SUP 70, or the ASR 903. Now, the CAT 4500, I've dealt with one of these. It's a rack mount switch that looks like a server, but actually let's show this a little bit bigger so you guys can see this. What it actually does is they actually have two sections. Section here, it's 16 ports drawn up like this. They divvy it up like that, and they have another one over here, but it's actually empty. So there's actually a panel right there. And what this does is it gives you a gigabit connections right here. Then they have a section over here, which is going to be like most 3750s and whatnot that have the 10 gig or the TE connection, and you're going to have fiber optic uplinks. So you can have up to, well, depending on how you set it up, you can have a massive amount of bandwidth available. Now this is a 4500E. When you fire it up, it runs iOS XE. And now depending on the version of iOS XE that you run will determine what correlates to the iOS version. So right now, and I've actually got this downloaded and installed, is if you download iOS XE 3.11, that is going to be the same running configuration capabilities of 15.4. Okay, I believe 3.10 is 15.3.3. So if you download this guy, that's going to give you the minimum requirements for the CCIE lab. Now, I have not figured out a way to get multiple 45 or CSR 1000Vs to run inside of GNS3 or in a virtual machine to where I can link them together and actually get routing to work. To me, I've got better things to do with my time. But that's one of the features that it gives you. Now, let's look at the way that XE actually does its job. Normally, when you download an iOS image from Cisco, whether it's going to be, in most cases, like an iOS image from, your 1841, you're going to download maybe a 60 to 80 meg file, and that's going to have your iOS image on it. 80. And what you're going to do is you're going to take that, you're going to install that, install the .bin file to your flash. Right? You're going to install that to your flash. You're going to set the boot statement to boot from flash, wherever it's located, and whatever the file name is for the iOS image you want to boot, and you're going to reload. And that's going to load that image into the running config. The way that iOS XE does it nowadays is different than that. iOS XE, you can download what they call packages, consolidated packages. Now, consolidated package, if you're going to download the whole thing, you're going to have all of these packages that are available. So you're going to have the route processor base. This is the base setup. The RP control. This is used for the control plane of the device. RP access, SSH for management. RP iOS. This is where you're able to take iOS 15 code and load it into a route processor package, and that's going to allow you to run iOS 15.x on your XE platform. So you don't have to get used to a new operating system. All you have to do is install iOS XE or install iOS 15, and then you're going to be able to utilize all of its capabilities outside of that platform. You have the ESP, which stands for the Embedded Services Processor. This is going to be the forwarding intelligence. They have the SIP base, which is going to be the Shared Interface Processor. You're going to have the SIP SPA, or the Shared Port Adapter. Now, you do see sub-packages right here, right? Well, what a sub-package basically is when you download the consolidated package, you download all of this. If you don't want to download all of that, you can download just a subsidiary or a subset or a sub-package. If you're going to do that, you need to download the provisioning file for that, and that will allow you to install just the RPiOS or just the SIP base. You may have heard of Rahman and how Rahman can be a bad thing. Well, not necessarily. Rahman can be good because it allows you to go into the bootloader of the device and actually make changes to the way things are done. So you can unset the boot from a particular iOS image. You can go in there and change the config register so it boots into Rahman every time. There's a lot of things you can do with Rahman. You do not have to update Rahman when you do this. It's a separate upgrade or downgrade or parallel depending on what you want to do. Now, with all this said, the idea behind all of this is modularity. If you were to download each one of these individually, the benefit to doing that is if you only wanted to do it individually, it could be a cost-effective savings for you. You don't need an entire package of options, would be the best way to put it. So it allows you to take whatever you need and install it with the provisioning file. Once that's installed, then you have access to whatever these are. Now, I have never actually deployed a XE platform before, so that's where the extent of my understanding of how that works goes away when it comes to that. So now let's talk a little bit about the control plane and forwarding, troubleshooting, and some of the other features that come along with it. So all these options up here kind of get rolled into down here. So just from a platform-specific architecture, we want to make sure that we exclude this. We don't want to be looking at platform-specific, because anytime you go platform-specific, there's always going to be limitations or reservation limits or something to that effect that's going to, not allow you to do what you may want to do. So instead of going that route, what Cisco has done is especially with the exams the way that they're going with CCIE, they're taking it and they just want you to know the iOS. Doesn't matter what platform it's on, you should be an expert in the iOS. Now, back with the version 4, 3, 2, and 1 platform or versions of the lab, you were on all hardware. So you had limitations to what each device could do. So I believe it was 3825s and 3560s inside of the CCIE route switch. I never took the exam, so I'm just guessing here. I'm really not sure. So you had 5 of these and you had 4 of these in the lab. So you had to stay inside of the platform's capabilities with an iOS image that you were given. So if that's the case, then you might run into an issue in the real world where the platform doesn't support what it is you're trying to implement. So Cisco has gone away from that model, and I'm kind of glad that they did, because it gives people like you and I a better chance of passing on our first shot because we aren't going to be limited. We're not going to have to deal with platform limitations. So we have some individual processes that we're going to look at and determine how each one kind of plays into the other. So we have the chassis manager. So the chassis manager is going to be how different operations on the chassis are going to be redundant. So it's all about redundancy when you're talking about modularity. So we have the chassis manager. We'll draw a chassis because that's what most devices are going to nowadays is chassis. Whether it's a Blade server or it's going to be a Nexus 7000 or whatever the case may be, the ability for a chassis manager to keep an eye on high availability, the route processing, you're going to have multiple slots for each. Meaning you're going to have 2 route processors. We'll just draw those right here. And HA attached to each one of those. So if one goes down, the other one can run the other 2. It's like having dual soup engines inside of your chassis. It makes more sense. And what ends up happening, if this architecture is anything like the 6509 or the 4507s, this gives you the ability to make sure that the RP, they're in constant contact, whether it's through stateful switchover or non-stop forwarding. We'll talk about these quite a bit when we get into the routing protocols and how we can actually use these commands to take a router out of the routing decision and move it into maintenance mode if we need to upgrade something. We'll talk about that a lot more. So it's all about high availability. It's all about being able to take one process and if a particular feature dies, if it gets attacked by a denial of service or a denial of service for a service on the device, it allows you to work around that without having to take down the whole box. There's a logger, so logging services for all modules. The iOS feature, that's going to be huge for you and I because of the fact that's what we're going to be dealing with most of our time. So it's the routing and the forwarding, 15 code, the route processor, and the iOS consolidated packages that we just talked about a minute ago. We have pluggable services, meaning integration of authentication and iOS. So it's going to be a good deal for you, especially with the advancements in the iOS or the routing protocol authentication and encryption that's out there with the HMAC authentication and things like that have come out recently, the ESP for the encapsulating something payload, I believe it stands for. Moving on, we have the SPA driver, which is a shared port adapter. What this is going to do, it's going to allow you to share interface drivers. So it's going to give you the ability to have one driver doing, say, SFP and have that same driver pushing out another one or pushing out another interface. Gives you a lot of flexibility. The host manager, interface between iOS and information gathering processes. Well, it's pretty much just that. We have the interface manager. iOS functions use the interface manager to provide communication. That's going to be a big thing because if your iOS can't talk to your interface, how is it going to apply those QoS settings you just set? It's not going to be able to do that. The forwarding manager, it's an ESP or embedded services processor module. It's the forwarding intelligence. It's going to be how OSPF and BGP make their routing decisions. We have the shell manager, all user interfaces, the diagnostic and user access for troubleshooting, things like that. We have the CPP or the control plane driver for high availability, and the SP shared processor. I'm not sure what SP stands for. I should have been a bit more specific. Drivers for each of them. So you're going to have a drivers module so that you can have drivers for each one of these options available for you. Now, like I mentioned just a few minutes ago, there is a distributed control plane for XE. With redundancy, there's 2 RPs for the control plane. So if one route processor dies, then the other one will take over for it. There's 2 ESPs for the forwarding. The SPAs will use what they call the input-output control plane. So ESP, the embedded services processor, takes the forwarding engine control plane, and then we have the SPA, or the switch port adapter. I'm sorry, that is not what that stands for. SPA stands for shared port adapter. I want to make sure that I was correct in my interpretation. Shared port adapter uses the input-output control plane. So that's iOS XE. Now, if you want to know more about iOS XE and how it really works, there's actually a very, very good Cisco Live 365. If you've never been there, I suggest you go check it out. There's a video up there. If you register with them, I have a CCIE account for Cisco. I use that. Register with Cisco Live 365, and when you go there, just type in. It's on the left-hand side. There's going to be a checkbox for sessions with video. You're going to want to click on that, and then in the search bar on the right-hand side, type in Cisco or iOS XE and hit enter, and go to, I think it's either Cancun or Milan. There was a really, really good 90-minute tutorial on how iOS XE really works, and it gives you the guy that actually wrote the code for it and actually built the actual the translation capabilities between iOS and iOS XE on the same box. That guy goes through immense detail on how this stuff actually works. So the reason I think Cisco put this on the exam is because of the fact that that's what they're going to be moving to as a solution down the road. So if I was you, I would be very familiar with this as you're moving forward, especially when it comes to things like your edge devices. You're going to want to get your ISRs out of there and put ASR in, or potentially move out your 6500s and put in 4500Es, something to that effect. So it all depends on how you want to do it, but that's my recommendation for you on moving your network forward. So if you have any questions, feel free to drop me a line. I hope this has been informative for you. I want to thank you for viewing.